Welcome back. In the previous video, we used XSS to steal cookies. In this one, now we will continue with using XSS to do a simple URL redirection. Let me first set up the scenario for you. So I have here an application hosted at port 3000. This is a legit application. I have given it a domain name of legitcompany.com. So now we can get to this application by visiting legitcompany.com at port 3000. To those of you who don't know, I'm just setting up a local DNS server via editing this host file. It is located at this location, C Windows System 32 drivers etc. Now back to the point. Now instead of pressing localhost, entering localhost every time, I can just visit legitcompany.com at port 3000. And this is our legit website. Just run this scenario with me. Now as an attacker, if you want to fool the users of legitcompany.com, you will set up an application. You will clone the application legitcompany.com in your own IPN port. Typically we use AWS instance to set up an infrastructure like this. So I have one set up here. So at port 127.0.0.1 5000. So this is equivalent to localhost. If you don't know, localhost actually is nothing but 127.0.0.1. So yeah. So we have set up a clone. This is clone of legitcompany.com. Typically what attackers do, they set up a machine like this and then they go buy a domain. The domain could be legit.company with 2y.com. This is almost similar to legitcompany.com. They buy a domain like this and this domain will be attached to this IP. So whenever people visit legitcompany.com, they will be assuming that they are actually visiting the legit application, but they are actually visiting the clone of the legit application. This is a scam server. So buying a new domain is something which is which could go costly for you, and at the same time reputation building is another thing. So you can't straight away buy a domain and send mail using it. You have to build a reputation. It takes a while. So this is how it happens usually. But if we have XSS in this application, we can have this legit domain redirect us to this malicious server, as in this application itself will process our request, our malicious request, that which contains our XSS payload, and after processing it, it will redirect us to this malicious server. Let us see this in action, but before we do that, I'll have to make a small correction. Our malicious clone is actually hosted at port 5500 or 5500. Now let's examine this payload. This script, what it does, it simply changes the window with whatever URL is written here. Right, in port 5500 or 5500, our clone is hosted. So if we are to copy this and paste it here, this is our legit website. It has the problem of XSS. This is the area. If you enter your script here, it will run. So we are entering the script of having the window redirected to 5500, right? Let me click on greet. See, it was so quick. Now we are at 5500. It is similar looking to legitcompany.com, but this is not the actual website. For clarity, if you hover over this, the tooltip is saying that this is actually a scam website made to look like legitcompany.com, hosted at port 3000. So this is one way. XSS is something which need not be very dramatical, like stealing a cookie. You can also use XSS this way. There are very many things you can do with XSS. I have shown you two. This is one of the things. This redirection thing is a thing which may not look very significant, but if you can chain it to another vulnerability, then it gets its impact. So in reality, even in red teaming, we don't we chain vulnerabilities. One vulnerability is chained to another, and that one is chained to another, and eventually you build that impact. So that is how you show impact to the developers, and this was one such way, doing a redirection. Now, how do you actually send this exploit to the victim? The users of the legitcompany.com. If I click on it, the greet button, notice the address bar. That happened way too quickly. Let me check the history. Yeah. So you have this. URL. If you're able to see here, a greet page is there, and the name query parameter is carrying our payload. Now, if we click on this gets us to the clone page, right? How do we make an exploit out of it? We can simply copy this and create a mail out of this. Hi user C of legitcompany.com. Please click on the below link to check the status of your order. Now, as the legit user, most of the users, they won't be able to recognize that this is an exploit, right? This is a JavaScript payload. All they will see is there being a legitcompany.com in the domain, and then they will click on it. Now you know what happens when we visit this link. It will take us to the scam.com, right? Scam page. Clone of legitcompany.com. Now here, as an attacker, you could just simply put a login page of legitcompany.com and ask the user to log in again. But the user will be under the impression that they are logging into legitcompany.com, but they are actually logging into your scam.com, and you capture their credentials there. This is how a typical phishing campaign happens. So it was made possible by XSS, right? Now, how do you go about finding if XSS is present in your application or not? I'll be showing that to you now. I have here Burpsuit Pro with me, and this is the Burpsuit's browser. I have legitcompany.com opened here. Let me just capture this request. So this is the legitcompany.com's greet request, right? So the first thing typically that we do with the XSS is to find if our input is getting reflected in the response. So my input is getting reflected in the response. So this is like a precursor to test out if special characters are getting reflected or not. So angular bracket, opening and closing angular bracket is something which is called a special character. So now we have a special character reflection here. So the next step is we will try and see if special elements like script is reflected or not. This is the script sent by the developers. I'll keep on searching. And yeah, the script that I entered here is getting reflected here. Now as a test POC, we can just show that you can just show that script alert 1 is getting reflected here, right? I can just copy this request, copy URL, and I can just paste it here in the browser. So this pop-up is generally shown as a POC. Note that this is not the final impact. We have seen the impact. You always have to report vulnerabilities along with the impact. This is a POC thing. Now, that was me entering the input and seeing if the reflection is happening or not. You could also have this thing where you can use the scanner. So burp scanner is here. There are very many options to this scanning. I won't be covering the subtleties, but just to let you know that we can just scan for the vulnerabilities and find the scan results in the dashboard. This is our scan. It is finished already. Yeah, our web page is our website is very small, right? Barely. I think there is only one page in it, and it has already found that our website is having cross-site scripting issue. So this is the general flow. You have you yourself doing inspection, and scanner like Burpsuit is doing its own inspection, and you check the results that is found by the scanner and try and increase the impact of its findings. So that's that. But nowadays things are changing very rapidly. If we go to repeater, you're able to see burp AI here. I have checked it out, and it is also quite powerful. So things are changing rapidly, and I want you to understand that this entire video series is not something which is targeted towards making you a specialist. It's a generic video. This is a explainer or introductory kind of videos targeted towards making you aware of the context, making you aware of the vulnerabilities, so that you don't jump headlong into VAPT or web appsec. So that's that. But the actual resource, the actual skill in specializing for XSS will not be found in this series of videos. You have to go through pentester labs. You have to go through Portswigger labs and very many other resources. You have to go through Medium articles and be in Twitter and try and see what other XSS specialists are doing, right? So that's that. And I'll be posting some links in the description for you so that you go through them and try and excel yourself in finding XSS. For now, we will be moving on to the we will be moving on to the remediation part of XSS. How will we stop this attack from happening? Remediation wise, first let us check out how do you go about doing output encoding or escaping the malicious input that we are entering as a payload. So if you remember, in our legitcompany.com's example, the input that we are entering, script alert 1, is getting reflected as is. What if we can change this special character into a not so special character? As in, we will change we want the script alert 1 gets executed because the script part has a special meaning to it. It is interpreted as a code by the browser. But what if we change the special character and make it such that it is not interpreted as a code? So how do you go about doing that? We will be seeing the example of that. This here is the server side code of our application, legitcompany.com. This is the server side code. Now we have two area. One is server.js. This represents the application server. Here also we can do output encoding, but this server.js it's running on Express node, and it has imported EJS, right? So EJS, the library that it has imported, the template engine that it has imported, it also has the functionality to escape our input. So here we have this dash sign, right, or minus sign if you will. If we change this to an equals to sign, then it will do the escaping for us. Our malicious payload or our script will eventually end up here, and because of this equals to sign, it will do an escaping in our input. Let me save the code and we'll run this now. We'll run this application after changing the code and see if our script gets executed or not. So I've rebuilt and rerun the application. Let us reload this. Now let us try our vanilla payload. Right, if I do greet now, see, we're not getting the pop-up. Let us check the source. See, the opening tag, the symbol is out escaped or output encoded. Let us also check this out in burp suite. This is our original request. Let me do send now. See, here also the special character is changed. Now earlier it was being interpreted as a code because of this opening tag, but now since encoding is applied on that special character, it won't be interpreted as a code. Why did this happen? Because we had server-side functionality. So it was by default it came with equals to sign. It was me who made this intentionally vulnerable by using the dash sign. But yeah, by default it came with equals to sign. So if you keep it equals to sign, it will escape the malicious input for you, right? So that's the idea. So this was shown on Node and embedded JavaScript engine. If it would have been a different stack, there might have been different there would have been different library and functionality to get this escaping done. Now let us look at using CSP as a mechanism to prevent XSS. So CSP is HTTP security response header. It what it actually does, it, even if the attacker is able to inject their script in the web page, the CSP will prevent it from getting executed. We'll be seeing a demo of that now. I am rebuilding our legitcompany.com to its original state, as in the template I have added this minus sign again. So this will cause the XSS to happen again. Right, it is happening. So we have XSS getting executed. It is back, no escaping or anything. This is an inline script, by the way, script which is loaded in the body, script which is found in the source code. Now what am I going to do now? I'm going to implement the CSP header and rebuild the application, and this should not execute once after the CSP header is implemented. The code for the CSP header here, let us add this in our server side code, in our app server. Okay, where do I add this? Let me add it here. Before the actual greet page is loaded, I want the headers to be set. So here, this is with this line we are setting the CSP header. The content of the CSP header is to be default src self, script src self. This is the part which will prevent that inline script from getting executed. Let me save this. Let me rebuild my Docker instance. So our instance is up and running. Let me reload this page. Let us try and execute the code. See, we are not getting the script execution. Let us check the response. The source code, even though we have it unescaped, we are not able to execute the script. Reason being, let us also check the bug suit. This is our original response. We have output encoded response that which came from our escaping that equals to sign that we did. Now let me send the request. This time it will be a new response. The malicious script tag is back, but if you check the header, let me show you the previous header. See, there is no response header as such where we can see CSP. But if we are sending the request again, this is the new request, we have CSP header set. Now it is this response header which is preventing the script from getting executed. That's what the CSP header provides for us. It when the script SRC is set to self, you can't have inline scripts getting executed. You have to load the scripts from a different origin. I'll ignore that last part, but to keep it simple, even if you are able to inject your script, right, even if the attacker is able to inject their script, this CSP header will prevent it from getting executed. Now let us look at the example of our cookie stealing exploit via XSS. Let us try and prevent the XSS from accessing our cookie. We can do that by setting cookie attributes. We'll be seeing that now. I have this application, right? This is that cookie stealing exploit application. I've already built and run it. It's running here, yeah. If I am to log in, I'll get a cookie, right? Let us access our cookie via script. Let me alert document.cookie. So I'm getting my session ID that is stored in the cookie. So we can prevent this from happening. Exactly. This pop-up will still happen, but this session ID or the cookie which is has the attribute properly set, this data won't be displayed here. Let us also check the cookies attribute. So these are the cookies attributes. We have HTTP only, secure, and same site. Now let us focus only on HTTP only. So nothing is set here. So browser is assuming that this is set to false, right? We have to set it to true. We have to set it to true in the server side so that when the browser receives this cookie, it should be set as true. Now let me go to the server side code. So here also it was deliberately set as false. Where is that code? Yeah, it was intentionally vulnerably set so that I'll be able to demonstrate the cookie stealing exploit. But yeah, let us set it back to true. And let me turn off my Docker instance. Let me run it again. Let me revisit the application. Now let me log in. Now let us check the cookies attributes this time around. See, HTTP only is set to a correct symbol, as in HTTP only is set to true now. Now let us try and see if we are able to access the cookies data. Right, script alert. XSS is working. Let me do document dot cookie. See, that session ID data is not visible now. This happened because of HTTP only being set to true. So even if XSS is possible, we are safeguarding our cookie, right? We are limiting the attack surface or the impact being caused by XSS just by turning on an attribute, that is turning on HTTP only. Now there are other remediations or preventions for XSS. We'll ignore that for now. What I want for you to understand now is to take a reality check on XSS. So XSS is a threat, but you have to show the impact. Otherwise, there is not much to it, right? You have to convey the impact to the developers or the stakeholders. You have to show that I'm able to steal the cookie. You have to show that I'm able to redirect the site, and that is that. And I would like to share a short event that happened to me. I had a colleague who found an XSS, but in this case he was able to do it by injecting his payload in the HTTP request headers and in the request header, and that was being reflected in the response. Now how do you it's a reflected XSS, but how do you exploit this? How do you send this to the victim? You can't, right? In our case, we were sending the link to the victim and they were supposed to click on it. But if your payload is in the header, the request header, it won't go in the link. So how do you go about exploiting it? You have to call the victim and tell them to inject the payload in the script. So you understand, it's unlikely scenario, right? It's as good as asking for their password. So in that scenario, you are not able to show the impact. You are not able to convert your XSS into a full blown attack. So you have to understand this is not a risk, and as per that you have to revise your risk rating, or as per that you have to convey that this XSS is there, as in you are not doing output encoding or you are not using safe library, but impact wise it is minimal. So you have to revise your risk rating or statement accordingly. Another reality check that I want you to get is, sometimes in your testing, you might see script alert 1 in the response in your Bubsuit response, but when it comes to the browser, it is not executing. So in your response, if the response was in JSON, what can happen, the front end or the browser component like Angular can actually bind to that data and make it inexecutable, make it safer. They call this Angular binding. React and Vue also does this. So you need to be sure that your response is actually getting executed. Otherwise, Angular has played its role, or CSP could have played its role. Your script might end up in the front end page, but CSP intervened and it did not execute. So just because you are having script alert 1 in the response in Bubsuit, you shouldn't make tag that as a vulnerability. You have to check it thoroughly. I'll end it here. This video has went on way longer than I expected, but I guess time is the cost you have to pay for knowledge. So thank you so much for watching. I'll see you in the next one.